So we've pulled up another scan here. This is a carrier with 6-inch wafers, and I want to show you the statistical analysis that we can do on such a carrier. So I can load a template for analysis, which in this case is set up for the 6-inch wafer. So you can see the black lines here, and also some exclusion areas. The red circles are exclusion areas. But with this template loaded, we can then very easily show the statistics for this carrier. And so what this data here is showing is total pocket statistics, total platen or carrier statistics, and then individual pocket statistics as well. So you can see in this case, the pocket emissivity is pretty consistent, but if you look at the platen or carrier statistics, it's a much higher emissivity than the pockets, which again, in general, is not a wanted condition and will lead to temperature non-uniformity. So show you one final carrier that we just scanned because it's got some very important information. So first of all, you can see again within the pocket here, there's a very different emissivity towards the inner edges of these, or the inside of these pockets, compared to the outside. So the purple here has an emissivity of around 0.83, whereas going towards the green, you're up about 0.88. And again, that's going to cause temperature non-uniformity across the wafers. But you can also see with this pocket that there's a crack here. And we can actually zoom in on that crack by doing a surface analysis. And let me move the analysis window to the crack. So as I move this over, we can zoom in on that crack. And it turns out that this is a microcrack that's the result of many, many temperature cycles, bakes of the emissivity carrier, and of course temperature cycling during deposition. This crack is not easily seen by eye, and typically these microcracks you cannot see by eye, but this obviously will lead to temperature uniformity, but maybe even more importantly, if you continue to use this carrier over time and heat cycle, it will actually explode either in your oven or in your emissivity deposition chamber, and obviously that's not a good result.